Okay, let us discuss this problem. This is an easy problem. This says a uniform rod of length L. So I have a uniform rod of length L performs a small oscillation about horizontal axis O dash perpendicular to the rod and passing through one of its points. So something like this. We have a rod and the length of the rod is L. Mass is not given, so let us assume mass is m. In the final answer, I think mass has to be cancelled out. Now question says this performs a small oscillation about any point O, and there is a axis. This axis goes inside the plane of paper, so this is O dash axis. So this is axis of oscillation, basically that is going inside. Now question says find the distance between center of inertia of rod. So let us say center of mass of the rod is somewhere here. So this is center of mass. We have to find the distance between O dash and center of mass. So let us say this distance is h. So that time period of oscillation is shortest. So we have to find time period, that is the minimum time. So we have to find h for t should be minimum. So what I should do, the plan will be something like this. We have to find time period and then I have to differentiate with respect to h and then put it equals to 0. So this will be my plan. Now if you remember, for any compound pendulum, time period is given by, this is a fairly easy problem. T is equals to 2 pi under root I by mgd. So this time period is given by, if you remember this result, you have to remember 2 pi under root I by mgd, where d is the distance between center of mass and point of suspension. So in this case t is 2 pi I, so I about O dash, so let us write I about O dash divided by mg, and in this case d is basically h. I O dash, this will be, now I can use parallel axis theorem. So moment of inertia about center of mass is m L square by 12, and then I have to add a term plus mh square. So this is I O dash. Now time period will be 2 pi I O dash will be m, let us take common. So we will have L square by 12 plus h square. This is I by mg h. So m goes out, so we will have time period is, are you getting or not? So 2 pi under root L square plus 12h square, and this divided by, we will have 12gh. Now I want t to be minimum. So of course if t is minimum, t square will also be minimum. So why not I simply put t square, differentiation of t square. So if t is minimum, t square will also be minimum. Are you getting? Why I am doing this? Because differentiating t square will be easy. So I think all of you can do this one. So let us do this one and find the answer. Okay, so if you follow the steps, we will have t square, that will be 4 pi square, and this will be L square plus 12h square divided by 12gh. Are you getting? Now let us differentiate t square. So I can use the next page. So this is t square is 4 pi square L square. If I want, I can also divide. So let us take 12g common. So we will have 12g outside. and you will have L square by h plus 12h square by h. So if I differentiate, so this is t square, t square by dh. This is a constant, so it will remain as it is, 12z. So this is a constant term. Now L square by h square, so this will be minus L square by h square, and this is simply 12h, so you will have 12. Are you getting? So if you put it equals to 0, so L square is equals to 12h you will have. So h will be basically L square by 12. This is h square. So from here you can have h is equals to L and 2 root 3. So this is the distance between center of mass and the point of suspension. In that case, you will have time period will be minimum. Now question also asks what is the time in this case. So you see, so time is given by, so let us plug this value for t square. So you will have 4 pi square by 12z. Plug the value of h, so L square by h, L square by L by 2 root 3, so 2 root 3 will go on the top, plus 12h, so you will have plus 12. H is nothing but L by 2 root 3. Are you getting? So if you solve, so you will have t square is equals to 4 into 3, so you will have pi square by 3z. This LL goes out, so you will have 2 root 3L plus 6, and this is 6, so 2 root 3. Are you getting? You cancel it out, so 6 I can write 2 into 3, and 3 under root 3 goes, so you will have 2 root 3. So this is basically 4 root 3. So you will have 4 root 3L, 4 root 3L pi square by 3z. So this is t square. I can write t is equals to t square is equals to 4 by root 3 pi square L by z. So in that case t will be under root 4 by root 3 pi square L by z. So this will be the minimum time we will have for this system. You can also write the same expression if I take 2 pi common. So I will have 2 pi under root Ly under root 3z. Are you getting? So this is the minimum time period that is possible in this case. So if you have a rod that is suspended through a point in the rod, you will get the minimum time period, that is 2 pi L by root 3 into z, and this minimum time is possible when h is equals to L by 2 root 3. If you have a good memory, then you can remember this result, that the minimum time period possible for a rod when it is suspended through a point inside the rod, the minimum time period will be possible if the distance between center of mass and point of suspension is this. If you remember, then this is very nice. Okay, let us go for the next problem. So you see, in this problem what we have done is, we have used the compound pendulum formula. Time period will be 2 pi I, 2 pi under root I by mzd. This result you have to remember. Otherwise you have to prove this result. If you remember, that's fine. Now, moment of inertia in this formula, I is the moment of inertia about the point of suspension. That is very, very important. So you have to find moment of inertia about point of suspension. And d is the distance between point of suspension and center of mass. In this case, this distance is equals to h. And then you have to find the minima condition, that is the differentiation should be 0. If you want, you can also prove the second differentiation of this. This comes out to be this is minimum, so this comes out to be greater than 0. So differentiate this once again. In that case, you have to prove that this comes out to be greater than 0, because this is the minimum. So time period, so you have to basically do, you can prove this. So you have time period expression for this is this time period. So what you can do is you can prove yourself d2t by dh square. For this to be minimum, this has to be greater than 0 when h is equals to the result that we have, that is L by 2 root 3. So this should be greater than 0 when h is equals to L by 2 root 3. Now let us do this yourself. Even if you want, you can just take a break for 5 minutes and do this calculation and prove that this comes out to be greater than 0. I am not going to do this one. So you have to do this one for yourself, that is d2t by dh square should be greater than 0 when h is equals to L by 2 root 3, because this is a minimum time period, and time period will be minimum when the second differentiation of time period should be greater than 0. We'll discuss the next problem.